For question 11, if you just are after the solution, pause the video, you can have a look at it and work out what you want to know. If you want the explanation, stay tuned because here we go. The first thing we have to do is expand 2 plus x to the power of 4. It's a binomial expansion and there's a process for this. So we take the first term in the brackets, 2, we raise it to the power of 4. We multiply it by 4c0, but 4c0 is just 1, so we don't write it. We also multiply it by x to the power of 0. But we don't write that because it is also 1. Then we add the second term, which is now 4c1 multiplied by 2 to the power of 3, the powers drop 1, and x to the power of 1, but we don't have to write that. Notice the power of x has gone up 1. And then we add 4c2 multiplied by 2 to the power of 2. Again, the index has dropped 1, and x to the power of 2, the index has gone up 1. Then we add 4c3, 2 to the power of 1, x to the power of 3, and finally we add x to the power of 4, which of course is being multiplied by 4c4, which is just 1, and also 2 to the power of 0, which is also just 1, so we don't really have to write that. Now we need to solve these combinations that we have here for C1, for C2, and for C3, and we can use factorials to do that, but since it's such a low number, we can just quickly draw up a Pascal's triangle and let that help us. So here we are, and we look at the row which has 1, 4, has the first two numbers, and we know that 4c1 is going to be the second number in that row, so it's going to be 4. And then the 4c2 is going to be the next number, which is 6. 4c3 is the next number, which is back to 4. And 4c4, if we used it, it would be 1, but the two n numbers are always 1, and we don't really need to write them because we're multiplying. 1 times anything is just itself. Well, that gives us the 16 plus 4 times 8x to the power of 3, of course, 6 times 4x squared, and 4 times 2x cubed plus x to the 4, and that gets us to what we had to show, 16 plus 32x plus 24x squared plus 8x cubed plus x to the power of 4. For part 2, it says find the values of x for which the expansion is the exact same expansion equals something different, but it's looking different. So what we do is we look at it and go, hey, it kind of looks similar to what we had, and if we wrote it here, 16 plus 16x plus x to the 4, we would notice, oh, these three terms that we had before have now been kind of compressed into just 16x. So the 32x plus the 24x squared plus 8x cubed, instead of writing all of those, we write 16x. So for this to be equivalent, those three things must equal the 16x. So we have this equation that we just have to solve, and let's collect like terms. So move the 16x over to the other side, and rearranging in descending powers of x, we have 8x cubed plus 24x squared plus 16x now equals 0. We've done 32x minus the 16x. All right, this sum is nice because there's no constant. We can factorize out 8. We can also factorize out x, and I suggest we do that, and we will get 8x times in brackets x squared plus 3x plus 2 is equal to 0. Now, if we can factorize the brackets, of course, we do this to use the null factor law. We'll get x plus 2, x plus 1 equals 0. And so finally, any of the factors of 0 gives us a solution. So x equals 0, or x equals -2, or x equals -1, and we're finished.